Howdy do! Right, it's time for a hapless how not to. I am building a little panel. I say a little panel, very straightforward, because I've already got all my pump controls sorted. So this is literally PID, probe, and controlling basically my HLT. And the probe is going to be going onto the input of the mash tun from the HERMS coil. Easy peasy. So that's basically it. You know, I'm doing this in the simplest possible way that I can do it to achieve what I need to achieve. I'm only, I think it's either a 2.7 or a 3 kilowatt element, so that's all I'm doing. It's in the Burco boiler, so happy days, nothing too complicated. We hope. So, I'll reposition the camera, I'll show you the basic gear that I've got, and you can follow me through doing the project. I haven't really thought this through too much, but hey, it'll be alright. I'll go through the sort of the basic equipment that I'm going to be using, the basic tools that I'm going to be using, the tools that I haven't got, the tools that I've lost, etc, etc, etc. So, hope it's useful. I doubt it. Right, okay, so I think the image is going to be alright. I've had to close the blinds because the sun's belting in through the windows. So let's run through basically what I've got. So, plastic adaptable weatherproof box, Inkbird PID, 25 amp solid state relay, collar for the PID, PT100 probe. It's the dual sensor, so 2 resistive cables on there, which you can use. Little glands, bit of chocky block, which I didn't want to use actually. I wanted to use some DIN rail mounted connectors, but suppliers didn't have any. Plug top, that's how it's going to be supplied. Said it's only a sort of 2.7 kilowatt element, and it's a Burco. It's on a plug top now, so I'm going to be going a bit heavier duty on the cable just to keep the heat down best I can. And then I have got a weatherproof socket. Sorry about this, shit camera handles. So yeah, weatherproof socket. 1mm flex, that's for the lower voltage side of the PID. 2.5mm flex, which obviously I'll strip part of for this. That's going to be the supply in, and that's also going to be the feed to the socket. Nylon washers. I've got some stainless steel washers, and I've also got some silicone washers. Both the silicone and the nylon washers, or sorry, not nylon, fibre washers, are rated at 300 degrees. So you'll see why I'm going to be using that shortly. Now, I've got a piece of DIN rail, cheap as chips from an electrical wholesaler. You're talking sort of £1.30, £1.50 for a length of DIN rail. Excuse me. I haven't got a mounting plate inside of this box. In an ideal world, that's what I should have done. Didn't think it through. So I'm trying to sort of now decide, and I think I have decided on the rough locations for things. So we're going to have heatsink. I think what we're going to do with that is, oh sorry, wrong way around, is have that around about there kind of mark. That is going to be sat on top of the rail. So done. That's going to be sat in the bottom of there on top of this rail. But we'll get to that in a minute. PID, obviously we've got quite a bit of clearance. It's quite a deep box this. So PID, we're going to be looking at having that there. Now, as far as inputs and outputs, I think what we're probably going to do is these are, let's have a look, excuse me, M20 by 1.5, absolutely fine. So, I mean, 2.5 will go through that fine. So what I will probably do Should I use one or should I use two? Should I use a separate one for the probe? Seems a bit extreme, doesn't it? Okay, well, I'll decide later. So basically, I'm going to have one here. That's going to be the output to the socket. And then I'll have another gland here, which will be the mains input. The probe, haven't decided. It seems a little bit OTT to have one of them because it's never going to close up on that. So I may actually squeeze that one in with the mains cable. Don't think we're going to get any sort of issues with that, but we'll see. So, job one. Let's cut this rail. Okay? No point you watching me cut rail. Anyone can do it, apart from me. Okay, that's that cut to length. And as you can see, perfectly not straight. But this is a hapless how-to, so if it was straight, it would just not be in keeping, would it? So, this needs to be mounted in the box like that. Now, you can't clip that on and off. It needs to sit in there first. So, slide the heatsink on, get things positioned. Happy days. Yep, that'll do fine. Okay, and there's some nice little grooves in there to get my screws into. All I'm using for screws is some, I should bolt it, but doesn't matter because I'm going to be spacing it. We've got feet on this and doesn't really matter, it's all going to be good. So I'm just using some 1/4 inch 8 screws. No, they're not. 1/2 inch 8, sorry. Don't get caught. Okay, right, so this is where we're basically going to be using the washers. And basically the reason that I'm using these, obviously contactor does generate quite a bit of heat. Mounting it on the dim rail will help. I'm also going to be putting some thermal paste on there, back of the contactor. And that basically helps with heat conduction. You're not going to get any air gaps or anything like that. It's just going to do the job a whole lot better. Now, there is obviously still going to be quite a bit of heat on the rail. Not massive amounts, but enough to cause concern, and obviously on the heatsink. So what I've decided to do is silicone washer, stainless steel washer, fibre washer, that's 300 degree rated, and I am basically going to sit them underneath the rail and mount it that way. I'm also going to do the same with some slightly bigger ones, slightly bigger setup, because that's all I've got at this current moment in time, underneath the screws of that, because that does move, so it needs securing. I will possibly just secure it at one side. That's all it needs basically. So let's crack on. 1 watt, 2 watts. Let's firstly just see how high this sits. That under there, probably a bit too much. That'll be fine. So again, I'm going for fibre, stainless steel and silicone, completely OTT, but it doesn't matter. So I'll get all this positioned ish. Let's get it screwed down. Yeah, put one in at the other side. Pink's pretty colour. Okay, so that's in. Heath Robinson, but it's working. So, heatsink, washers, din rail, washers. So that is pretty well insulating this box as best as I possibly can do, without obviously sticking fans top and bottom to really keep it cool. But I'm thinking that's going to be okay. So let's now 100% decide where we're going to bring in these glands. and whether I'm going to be able to fit the probe and the supply in through the same gland. Okay, so yeah, it does, it fits, if you can see that. Now, I'm not entirely sure I should be running a sensor cable directly in parallel through a connection like that, but I think we're going to be okay. If not, I can pull it back out of there, put a separate one in, but I'm thinking for the minute we're probably going to be okay. So, on that basis then, we are one gland there for power to the socket. I say power to the socket, the power to the socket for the HLT, and then there is the input supply. So I'll get these drilled and I'll come back to you. Again, no point really watching that because it's not exciting. Okay, holes done. Very straightforward. And then let's put the glands in. These should be very snug. Yeah, very snug. Okay, let's put the locking nuts on. Locking nuts, I should say. Locking nits. I don't know what they are. Nip them up later if I need to. Okay, right, so next. Let's sort out the positioning of the PID. So that's going to be going to yonder, like that. Lid on. Now, a professional would obviously measure this, but I'm not that soldier. So I'll mark this out and away we go. Oh no. Pilot holes. Marked out, pre-drilled. In an ideal world I'd be using my Dremel, but can't find the ends for it, so I'm going to use this little, what do they call this? Coping saw? Can't remember. Any road up, doesn't matter. It is what it is. I wish I had my Dremel. Anyway, that's through. I'm going to go and do my sewing and I'll come back to you. Okay, so hole drilled. I won't put it too close so you can't see my rough edges. That saw was a pain in the ass, but nevertheless, it fits. It's reasonably straight. So let's put the collar on the other side. There's a screw on there, which is no use because there's nowhere to screw it into, but by the by. Okay, happy days. Nice and tight. Looks alright, doesn't it? And, oh, it don't fit, you bastard. I'm joking, it does. I think that's the first time I've swore, isn't it? It won't be the last. So we need to start getting this baby wired up. I think what I'll probably do is get the SSR on. Now I have got a few little screws. One might fit, one might not. If not, I'll just use some little tappers. Nah, none of those are a good fit. Stick with the tappers. Say tappers. Wood screws. Okay, let's get this baby on. So, I think we'll put the... So we've got low voltage closest to the inside of the box. Paste. Now everybody goes really OTT about getting this super straight and super covered. It will sort itself out in the majority when you put it on. but get it there or thereabouts. Happy days, and we'll wipe away some excess. Not as though there is very much, to be honest. Spot on. Let's start to get this baby wired. I'll cut some cables and I'll explain what I've done in a minute. You don't need to see me cutting loads of cables. And I will also be going OTT and soldering the ends. Back in a bit. Right, so here we go. I've got the supply cable coming in. I've cut the cables down, stripped the ends, haven't put the plug on that side, but what you'll also see is I've put a little chocolate block in there. I think it's probably going to be the easiest way for terminating things for the time being, so that's what I'm going to do. So that is the supply. So first job, get that onto the contactor. And then obviously I'm going to piggyback that over also onto the controller, onto the PID. But firstly, OTT, I know, but I'm just going to tin the end of these with my soldering iron and, well, because I can. Why not? Let's get this show on the road. So, job one. Let's put a crimp on end of hither. Just going to cut a tiny wee bit off that. Okay, I've also got this little flying lead, which is also going to go on there, and then that's going to go to the PID. So tinned as well. Let's get that crimped up with this fucking waste of space. Jesus Christ, you need to be fucking He-Man. Right. Okay. See what I'm doing. Okay, these can go into here, neutral and ground. It's very easy when you're going into chock block to actually push it in too far and end up barely getting a connection, so just ensure tinning it's the best thing you can do, and then just make sure that you are only going in with the copper wire. So that's on. That now, okay, this is going to be a bit of a pain in the ass because that's 2.5 cable, that's a 1.5 connector, which is the only one that will fit onto the PID. So I'm going to have to, well, hope that I can get it on. It's going to be as tight as a nun's crutch, but let's give it a go. Squeeze it in, baby. Perfect. Oh, right. to get a new one of these. That's going to do me head in. Okay, right, back in a minute. Okay, so that's all connected up. That's the supply in. Piggyback off. That's going on to the PID, the mains in. I've also made up a little fly lead for the neutral because I've terminated the neutral onto the block there. So I've tinned one end and I've put a spade connector on the other side. So connect this to hither. Nice and tight, and we're looking for pin 9 and 10. Although I haven't said this yet, there is no saying I am not going to die making this video. This is not me telling you how you should do it. This is me doing it my way. Now, I would strongly suggest that you don't do it and you get an electrical contractor or somebody that knows what they're doing to do it for you. That would be my recommendation. But I am not responsible in any way, shape or form if you do decide to do it and invariably blow yourself up, as I may do. So there we go, that's all on. So next I need to make up some low voltage cables to feed the doofer, the low voltage side of the SSR. I'll make them up and I'll come back to you. Okay, 2 flying leads for the SSR. So connect up. We're looking for pin 8 and 6. And then on the SSR, negative, which is 6, 4 on the SSR. Don't follow my instruction, I've told you though. There's no saying this is right. And 3 is positive, which is 8 on the PID. Done, done, done. Okay, you see what I've done? Okay, so just quickly run over, supply in on this flex, terminated neutral and the ground there, the earth, and then we've piggybacked off the supply into the PID, neutral off the block there, and then to the SSR, live, neutral, live, neutral. Happy days. Okay, let's crack on with the rest. So next we need to basically clean my fingers because I'm full of thermal paste, and next we need to get the socket on, which is going to be another flying lead, and I'll show you how I'm doing that in a minute when I've stripped the cables. Righty ho. Okay, so this is out to the socket for the device, the HLT. Earthed, neutral, and then finally yonder. Forgot to do something, didn't we? Put the probe wire through. Alright, I'll be back. Okay, right, so probe's through. Just need to connect that up now. So we are on 3, 4 and 5. Okay, the red one, onto 3, and 4 and 5. Okay, so all it leaves now is to put the socket on this end and the supply plug on this end. I'll come back to you when that's done and we'll see if we can blow myself up. Catch you in a minute. Okay, socket all tinned, ready to wire up. Okay, so we're all wired up, relatively straightforward. The hardest bit was getting the cable into the plug top, har. Anyway, right, so let's power on. See if anything goes bang. Bang, no, we're good. Right, so what I should do now is wet my finger and no, that really is not what you should do, dickhead. Right, okay, so that's it. Nothing on the Inkbird to suggest there's any problems. Haven't got a clue how to program it, so that's the next bit. I've got a kettle plugged into there at the moment. There's no supply to the kettle. Not surprising. Let's get it put together, programmed up. I'll come back to you and we'll do a test run on a kettle to make sure nothing explodes. Well, result, piece of piss. Well, ish. So, socket's on, probe's in the kettle, plugged in, nothing's gone bang, all fine, nothing getting too hot. So, I just need to do some programming. I've changed it over to the correct probe in the programming, but I'm just going to run the inbuilt self-tester, auto-tester, auto-tune, whatever you like to call it. But yeah, we're cooking with gas. So I'll get it mounted on the wall, get it all programmed, and I'll fit that into my HERMS. And I'll make another video on that because I've already started doing a upgrade one. Sorry you can't see my face. Honey, you okay up there? I've not electrocuted myself. I'm good to go. Have a beer. So, bing bong, over and out. If you need any input, drop me a message. Ciao. Final little addition to my little control build. So it's all in situ now. It's been, well, I'll show you one sec. Okay, so there it is in situ. Socket there. All this is weatherproof. Not as though it's going to get much, but tiny little bit of steam. But obviously you can see I've got all my extraction here, but my main boiler is well out of the way over here, so not going to affect this lot. I've got the probe into there. Obviously that's the out of the HERMS coil. I took the no leaks, ideal. I did have in there a thermal well, but I decided to take it out and just put that straight in there. Seemed like a much better idea. No heat loss at all then, so spot on. Spot on temperature, no heat on any of the cables. I guess it's been running for half an hour now, bit more. No heat on anything. Box is lovely and cool. What I'll do is I'll get my IR thermometer out. I'll pop the top off in about another 20 minutes or so, half an hour, and just make sure that there's no major heat on there. If there is, it's easy enough. I can just put a little fan. I can get some tiny little fans, one under there, one on top. Can't really see it. So easy peasy, but do you know what? I think we're probably going to do without it. And it's just circulating nicely through there. I've got my Inkbird probe also in the bottom of there, and that's at 65.4 and that's at 64.8, so I would expect that, because you know that's the output, that's in the bottom, so that's more or less spot on. So ideal, we're almost upgraded. Okay, yeah, so that's it. I know I said that was it in the last bit, but might edit that out or not. But yeah, happy days, really straightforward, really easy. PID, massive difference between that and the Inkbird. I mean, the Inkbird gets hot as shit, so I think it's only rated at 10 amp max. They're 3 kilowatt elements, so what's that? It's near 14 amps, isn't it? 13 and a half amps. I think I got that right. Who cares? So yeah, ideal. No major heat. Everything's working fine. It gradually brought it up to temperature. I think I put the water in there. When I chucked it in, it was about 60 degrees. It took about 10 minutes, 12 minutes just to, you know, get itself sort of sorted out, which is right. I'm sure you can piss about with the PID. I haven't got my head around. Very straightforward. I've put it through the auto tune function. Well, before I did that, I changed over to the PT100 probe, because obviously it won't work right until you do that at all, because it's got 2 sensor cables. Well, there's 3 cables, but 2 sensor cables, resistive cables I think they are, and that's it. Easy peasy, happy bunny. It's controlling the temperature perfect. PID, sorry, the Inkbird, it's fine, but the problem is with it is because it's just on, it's off. You know, there's no intelligence there at all. Bit like me, that I'm constantly overshooting. So boiler comes on for too long, overshooting, and it just isn't accurate enough. Which we knew, which is why we went for this. So happy days. If you've got any questions, leave a comment, whatever. I'll probably do a video when I get my head around the PID a little bit more. I'll probably do a bit of a video on sort of the basics of programming it. But do you know what? It looks really straightforward. I've just sort of glanced over the destruction manual, but I'll have a good old read. But I did sort of go out there, because I was a lazy bastard. Instead of reading the instructions, I had a quick look on YouTube, and there's very little out there about this particular model in the way of programming or setting up. To be honest, there's bits, but so yeah, it kind of makes sense that I've done this video, and hopefully I can do a follow-up video on how to program said unit. So thank you for watching. Bing bong, over and out, in it.